my friends, welcome back. In today's video, I want to solve the problem of the day from the Leetcode and the problem of the day from the Geeks for Geeks website. So let's get started. Today that I'm solving this problem is December 22nd, so I'm just going to go here and see what the problem is for today. So the problem, well, first of all, it's rated as easy, so probably super easy, but let's see. The title is maximum score after splitting a string. Okay, so it says given a string S of zeros and ones. So you're giving a binary string and it's asking you to return the maximum score after splitting the string into two non-empty substrings. And it says the score is basically the number of zeros in the left substring plus the number of ones in the right substring. Okay, that sounds very straightforward. Okay, so basically you're given a string of zeros and ones. You break it into two parts, right? All the different combinations that you can break that. But like it has to be non-empty. There has to be at least like one character or number in each of the strings. And you basically count the number of zeros in the left one plus the number of ones in the right one, and that's your score. And you want to find the maximum. And the example should make it even clearer. Like if you look at this, like if this is a string that you have, these are all the possible combination that you can have, right, for non-empty substrings. So if you do, let's say, look at this one, 0, 1, 1, which is like these three in here. So that goes to the left, and the right would be 1, 0, 1, right? So the number of zeros in the left substring is 1. So 1 plus the number of ones in the right substring, we have only 2. So 1 plus 2, that's a 3. And then you do the same for all the different combinations that you can break that string, and you find the maximum. Okay, let's do that. And the way that they have it here is that they call the function max score, and the only input argument to the function is string s. And okay, let's do that. We can do basically the same thing. I'm just gonna go define max score, and the string is s. I'm just gonna go max score 0 for now. And because the thing that we want to return, it's the summation of the zeros in the left and ones in the right, I want to do the same thing. I want to go zeros in the left, that sets to 0. And then I want to go ones in right, that's, well, instead of setting this one to 0, I want to go, this is s dot count 1. So if you look at this example in here, right, in the beginning, like before we get started, we can assume that we have like an empty string to the left and a non-empty string like on the right side, which is like the whole thing in here. That's why I set the zeros in the left to zeros and ones in the right to whatever the number of ones is in the whole string s. And basically now all I want to do is to traverse the string s, start from the position 0 and keep going, and consider all the different combinations. This is like you can think of it as a greedy search, right? So I just want to go for I in range of obviously length of s. But if I keep it as length of s, the problem is that the last one is going to give me an empty string on the right side. I don't want that. So I just go this minus 1. And I want to go if si equals 0, then zeros left is incremented by 1. But if it's not 0, if it's a 1, then, right, I have to decrement the ones right. So ones right minus equal 1. Okay, sounds good. And basically after you calculate that, you can just go score equals like the summation of these two. So I'm just going to bring them over. It's vact plus this And then I can just go max score because I need to update that because like I'm looping, I'm iterating over this. So max score would be the maximum of max score and score, right? And then we want to return max score. Max score. That should be it. We can try the example that they had. So if I go like this is S, right? If I go here S and then say print, basically this guy can be copied from there to here. So I expect to see 5 when I run this. So if I go here and run it, it says 5. Okay, cool. So that worked. And I did actually put the code here as well in their website. It's the same code that we saw, and it was correct. It worked, and it says it's accepted, and it beats 86% of the users with Python 3. The runtime is really good, but as I said in the previous video, it's always a trade-off between the runtime and the memory usage, right? So you can actually like keep working on the memory usage, see what you can get there. Okay, so this is about the Leetcode problem of the day. Let's look at the one for GeeksforGeeks. And so they have 2 in here, the maximum meetings in one room. This is the problem for today. This is a medium difficulty, and this one is like a hard problem. So I would say let's look at this one. I know it's not December 22nd and it's like from yesterday, but this is hard, so it seems to be more challenging. So the problem is that there are n children standing in a line. Each child is assigned a rating value given in the integer array rate ratings. Okay, so the things like the words in bold are basically the input arguments to your function. So you have n, which is like basically the number of children that you have, and each child is assigned with a rating value, and the ratings is given to you in a list rating. So they actually didn't even need to provide n because n is basically length of ratings, but they do. Okay, sure. And it says you're giving candies to these children subjected to the 2 following requirements in here, right? The first requirement is that each child must have at least 1 candy. Okay, sounds good. You cannot have a child with 0 candies. And the second requirement is that the children with a higher rating than its neighbors get more candies than the neighbors. Okay, so we have to compare each child with 2 neighbors, the one on the right and the one on the left, and make sure that like if they have higher ratings, it's not saying anything about lower ratings, right? Or equal ratings. If it's higher rating, then they need to get more candies. So when you look at this example in here, n is obviously 3, and these are the ratings, right? So if we assign each of them 1 candy, so 1, 1, 1. So far we have 3, right? And then like this is 1, this is 0. So this guy is like has a higher rating than this one. So this one gets 2, right? So 4 candies so far. And then if we compare these two, this guy has more rating, like a higher rating than this one. So it gets 1 more. So 1 more here. So we have 5. And then like we can go through this example yourself as well. But I think it's pretty straightforward. At least we know what we're doing. And so let's get started. Let's keep this. And define a function called that min candies, for example. They had m and ratings, right? Cool. And let's see. The first thing that we need to do is to look at the first condition. It says each child must have at least 1 candy. So I want to do the same thing. I want to go candies equals 1, and that times n. This is just to make sure that like each child gets like 1 candy. And now I want to go for I in range 1 to n, right? We have considered 0, like it doesn't really matter. So from the first child, I wanted to compare it to the child next to it on the left side, see if it has a high rating or not. So I just want to go if ratings I, right, is greater than ratings I minus 1, it means that this child has a higher rating than the one on his or her left. So I just want to go, if that was the case, I want to go Candy's I, right, is basically Candy's I plus 1. Well, that's not how I meant it. I minus 1 plus 1. So it needs to get, because it has a higher rating, right, it needs to get at least 1 Candy's more. Okay, so that's it. So we have considered the ones on the left. Okay, now we need to do the same thing for the neighbors, or like the guys next to it on the right side. So I just want to do the same thing and plot. It needs a different loop because I want to like now traverse the ratings array from right to left. So I'm just gonna go for I, right, in a range of n minus 2, because we don't really care about the last one, and minus 2 to minus 1. So we need to go n minus 2 downgraded to to minus 1. We can basically say that like it's looping, right? The minus 1 is the last one, so it's minus 2 and minus 2, and it goes m and minus 3 and minus 4 and so on and so forth till it gets to the, like this one was exclusive, right? So we don't get to minus 1, we get to actually 0. So I just want to go if ratings I is greater than ratings this time, because we're going right to left, would be by plus 1, right? And then I want to go Candy's I. I don't want to add anything. I just want to go, that would be maximum of Candy's I and Candy's I plus 1 plus 1, right? Hopefully this makes sense to you guys, because everything should be covered in the first loop that we have, right? If not, then this is going to catch it, right? Let's say that like you've assigned something and like you have a list, and like you start traversing your ratings from left to right and everything is good. And now that we're like back traversing, like coming from like the very end of the list or array to the first one, I'm saying that if this was true, right? Let's say that like, for example, we have, just want to make a comment here. Let's say that we have, I don't know. Let's go 1, 1, 2, and then like 1 in here, right? Because like we initialized everything to 1, right? So like if that's the case, let's say you get something like this. So you compare this condition on the way back. You say, okay, I now is this guy and I plus 1 is this one. This is greater than this one. Then the candies would be maximum candies of I, so 2, and maximum candies of I plus 1, which is this guy in here. So that would actually work. Anyway, hopefully it's clear. If not, just like make sure that you go over it and like listen to this video 1 more time, 2 more times, and hopefully that makes it clear for you. And then like once this is done, you can basically go total number of candies, right? Or like number of candies that you have to hand out would be basically sum of candies, right? And you just, or like you don't even need that, so you can just return sum of candies, right? And that should be it. That should work. Let's look at the example that they have. If I copy this. I need to get 5 for this example. So if I go here and I say print the sky, right? And change that to small n. And if I run that, it says 5, which is good. And they have this other example as well. And I'm expecting to see a 4 when I run that. So let's just change that and this. And then if I run this, and I get a 4 here. That's good. So I did the same thing for this guy as well. I put it in my GeeksforGeeks profile, and it says that it successfully passed all the tests and everything. And so looking good. Well, I think that's it for today's video. Hopefully you guys enjoyed it. And please let me know if you have any questions or comments in the comment section of the video. I'd be more than happy to answer those questions. And thank you for watching me. Please don't forget to subscribe to my channel to support me and also to get notified when I upload a new video. And you guys have a good one. See you all in the next video. Take care and bye-bye.